Hi everyone. So I'm here today to talk about Fermi-LAT and its role in the era of time domain astrophysics. So I'll just remind you what Fermi is. I think most of you know, but just though it's nice to remind it of the energy range and everything. I'll go through some of our shifts that we do for detecting transient events, a little bit about our monitored source list and our light curve repository, and then what we do for gravitational wave follow-ups. So Fermi was launched 16 years ago. We're not as old as Swift, but we're getting there. On the 11th of June 2008, which is not my birthday. And we have two scientific instruments on board. So we have the LAT, which is the Large Area Telescope, and the Gamma Ray Burst Monitor. So together they cover a huge energy range from 8 keV up to above several hundred GeV. So a huge dynamical range. Here's some technical information about the two detectors. So the Gamma Ray Burst Monitor sees the entire unocculted sky, whereas the LAT has a large field of view and it surveys the entire sky approximately every 3 hours. I won't go into the details of the instruments. They're there if you want to look at them. I think most of you know this by now. I just wanted to point out, like Swift, all our data are public, as you know, and we have a guest investigator program. And recently we've noticed that we have a much growing emphasis on both multi-messenger studies and analysis methods to further develop what you can do with Fermi, and also, of course, machine learning. So obviously, as we all know, multi-messenger studies are becoming more and more important. So Fermi turned 16 in June. Our spacecraft and instrument performance is excellent. We have no consumables, so in theory, you know, there's nothing that's going to run out. We did have a problem with one solar array drive a while ago, but we changed our pointing strategy, so that's fine. And any of the gradual degradations we have in our instrument components, we can compensate for with calibration. So everything's looking really good. Like Swift, we're decaying down our orbit. The lifetime of the orbit does extend to the mid-2030s, but we're actually preparing for a series of maneuvers to raise the orbit back up. The engineers have been studying these. We have more than enough fuel on board to do this. You don't, in fact, need very much at all. And we're not going to do it until the end of 2004, because even though we can leave it turned on during that, you know, you don't want to risk that you're doing some maneuver, and then, you know, the neutron star merger of the century happens. So the plan is to raise the orbit to higher, and this will mean there'll be less collision avoidance procedures we'll have to do. That takes a lot of our mission planning time at the moment, that you just have to watch out for these potential collisions. So when you go up to higher orbits, there's less of them. So that's interesting for us. Obviously, we're in the era of time domain astrophysics now, and we have a unique and highly dynamic energy range. As I said, we cover an enormous part of the spectrum. And our all sky survey provides both instantaneous access, but also the history. So you can go back and look at all of the gamma ray sky for the last 16 years. So we have real or near-time real observation data events anywhere in the sky. So for GBM, within 1.5 hours, and for LAT, within about 3 hours. Typical time to cover 80% of a gravitational range is about 1,000 seconds. And then, of course, you can archival searches from milliseconds to years. We have real-time monitoring and automated communications, and our data are available immediately after processing. This takes 6 to 8 hours before the data are available, and they're all public after that. And then, of course, we have partnerships among the science support centres, the community, the instruments team, to constantly develop our analysis packages and to enable innovations in our tools and analysis. So when Fermi was first launched, this is what we had in terms of transient searches. So here is the kind of time scale of the alert, and then here are the various different packages and systems that we had, and these would then be the objects to which they're most suited, these kinds of transient searches. But now we have a whole suite of tools to do various searches in the data, both in real time and in response to GCN, to looking back to GCN notices. So the LAT transient factory, the burst advocate tool, GBM onboard notices, and then at longer time scales, we have obviously our catalogs. We have the looking for flares from AGN, and then Fermi all sky variability analysis. So a whole slew of analyses and pipelines, each tailored to different kinds of alerts on different time scales. We have two types of shifts that we do within the collaboration. We undertake these typically for a week at a time. There's the flare advocate search, and the burst advocate shift, sorry. So flare advocates are concerned with looking for flares on timescales of 6 hours up to a day, and we release interesting events as GCNs. And then the burst advocate, they perform dedicated follow-up analysis on any GRB that was in the field of view of LAT. So any GCN notifications that we get from BAF, from GBM, we follow up to see if it was in the LAT field of view, and we release a GCN if we detect something interesting. We have a monitored source list. This is more interesting for AGN people, but any source that ever exceeds a flux of 1 × 10⁻⁶ gets added to this list. It started off with 25 sources. Now we have 207, and those data are sent to the FFSC every day. The data are analyzed and they're there, so you can just quickly see the light curves, you know, on different time scales and everything. Again, this is more interesting, I guess, for AGN than for GRBs and gravitational waves. We also have the light curve repository. If you go to this website here, you see a map of the sky, all the Fermi objects that were variable in our most recent catalogue. You can click on any of them, and then you can see the light curve over the entire history of the mission. If you want, you know, you can zoom in, you draw a box, and you can see, get it in more detail. And you can search over different time scales, 3 day, 1 week, 1 month. And you can select the different types of analyses you might want to do here. So that's available for a large amount of sources in the Fermi-LAT catalogs. Okay, so what about O4 and Fermi-LAT? So this is our gravitational wave follow-up pipeline. We have various different types of analysis that we perform once the data are downloaded to the ground. So this is not in real time. This could be 5 to 8 up to 9 hours after the data were taken. And then we plot the results on a public webpage. I don't really have time to go through the different analyses, but basically there are different ones that we do: fixed time interval, adaptive time interval, LLE, so the low energy data, and then PG wave, which is kind of Mexican top hat kind of an analysis where we assume a certain background level and look for data that are above that. So far in numbers, O4A and B. So these are the events that we have done follow-up analysis on, so nearly 50% of them. And the way they are classified by LIGO, Virgo, CAGRA, these are the significant ones, these are the non-significant ones. And of the significant ones, they're classified UVH, terrestrial, and neutron star black hole. And then this is showing the full distribution of all the events that we followed up. So if you want to see our results, they're available as the data get analyzed at this website here. The link is there. You can see the maximum test statistic that we had for the adaptive time analysis in this column here. And then if you click on the right-hand column, here you get brought to the analysis report page, and this shows you for each of the 4 different types of analyses that the pipeline runs, the results. So this is all work of Nicolo Di Lala, and you can click in then and see all the various sky maps and the different results. For the GRBs, within 90 minutes, no wait, what is it? Within 1 hour, we covered 90% of the error region for half of the GRBs. And within an hour and a half, we do that for about 75% of the gravitational wave alerts. Sorry, not GRBs, gravitational waves. So that for O4. I just wanted to make a plug that last Tuesday on arXiv, we submitted our paper on GRB 221009A. So you can go and see that. It's not yet accepted, but we posted it on arXiv to coincide with the Fermi Symposium. I'm actually nearly finished, so we're going to get back some of our time. I also just wanted to advertise this. If any of you have kids or people you do public outreach, this is a very nice video just about visiting a gamma ray burst. The link is there, that we made to celebrate 50 years of GRB observations. And I'm going to finish there. So we have a very strong and vibrant collaboration, strong engagement with the community. I think Fermi-LAT has a big role to play in this era of multi-messenger astronomy, and we're constantly improving to respond to the needs of the community. And our performance is excellent, so we're hoping for many more years of LAT observations.